everyone. It's nice to see everyone in person and online. For those of you online who I've not met before, I am Amanda. I'm the CE here at Cyma. I'm not going to talk for too long, as I am definitely not what you all came here for today. Right, the team have been working hard over the last few months to establish the knowledge space, and our aim really is to build and drive a community based on knowledge sharing, collaboration and thought leadership. So I'd really like to thank you all for making the time to attend today's session. I know everyone is pretty busy. We've run a number of successful webinars already, as well as an in-person event, and I am pleased today to introduce Jon Hulme, who over the next hour will be speaking to us about how to prevent cloud cost overrun. Jon has a wealth of knowledge and experience in this domain, so I won't take up any more of the air space in here, and I will hand the talking stick over to you, Jon.
Thank you, Amanda. Welcome everyone to this webinar. So this is a webinar we presented internally a little while ago, and then thought we'd share it out with the community. So let's kick it off. So just as an agenda, there we go. So just going to go through a bit of an introduction, then a bit of context setting, some understanding of where cloud costs are generated, how they're generated, some built-in tools we can use for visibility on costs, then some optimization strategy around rate and usage costs, then some looking at a few workbooks and dashboards that can surface some of those strategies and recommendations, and then finish up with some key takeaways. It's jumping around. All right. So the focus of this webinar is primarily on Azure and AWS cost optimization. We're going to kind of keep the concepts general, though the ideas will apply across all clouds. Not going to go sort of in depth on any specific service, but again, keep those concepts general that can be applied across the board. So, number of services, as we deploy into the cloud, we sort of aim to push services onto this spectrum. Most of you will be aware of these service types. Generally in the cloud journey, we try to sort of go from left to right. The services on the right hand side, I guess more lean towards sort of less management, sort of simplify the management overhead. So today's session is going to cover sort of the cloud optimization across the spectrum of services as we moved to the right. And we sort of see the complications of sort of the on-prem to cloud management overheads and how that sort of eases as we get to that more sort of serverless space, and the handling the unpredictable nature of costs sometimes. So just to go through a few introduction points, just to highlight, there's not a single method to optimize for cloud costs. There's going to be multiple aspects that are going to come together, sort of for overall and ongoing savings. I'm going to delve into rate versus usage optimization. So rate optimization is the idea of lowering the cost, the per unit cost we pay for cloud services up front, where usage optimization is optimizing how we actually run those services once they're deployed, what we can do to run those in the most cost-effective way. So cost optimization is a great thing to do, but we just also need to keep in mind the trade-offs in other areas. So resiliency, security, operational excellence, these kinds of things. When we make something, if we turn off a feature, are there other impacts? So it's just some awareness there. And a key point that I'll probably emphasise throughout this is cost optimization is not a one-time exercise. You have a sort of, if you have some sort of cadence or regular schedule, but it's a continual improvement activity. Okay, so just going to move on to understanding some cloud costs and how they're generated. So this is a fairly simple example, but it applies across a lot of services. So if we take deploying a virtual machine into the cloud, virtual server, we pick a size, a tier, quantity. You may have a certain number of running hours per month that attract a cost. Have an operating system disk with a size, a data disk for applications that has a size and performance tiers. All good. But we need to add some management agents on there, security tools we need to put on. We want to do some log ingestion. We want to back up those data disks. All those extra pieces attract a cost. We want to attach the machine to a network, obviously, because we want to access it and we want to use the applications. That in itself, creating a network and a subnet network adapter don't really attract a cost. But when you want to actually move data around, more costs get added to the service. So data traversal out to the internet, or going between networks within the cloud, or going down to on premises. There's all costs for data moving out. Generally, data moving out of your cloud is going to attract a cost. So this is just to kind of set the example that while you have a sort of a vision to, we need to deploy a service, a VM and some disk, there are wraparound components and elements that will also add to the overall cost that need to be considered as part of any cost management strategy. Generally, purchase options to cloud, the most common is on demand, so referred to pay-as-you-go. So this is sort of the default option, fairly flexible. Basically, you pay for what you use. You spin up more services, your costs go up over time. You lower them, your costs go down. It's sort of pretty straightforward. The other option is a minimum commit. So this is a way to achieve significant savings by agreeing to use the cloud services for a minimum period of time. Costs can be more predictable. And I'll go into some detail on the options around this. Just a quick call out when you want to estimate costs. All the providers have their pricing calculators. They're great use for planning ahead of what your cost expectations are. It is I suppose a data quality exercise. You're only going to get out quality out based on what you put in. So know what you're designing, when you're going to what you're aiming for. If you sort of do this early on in a design process, you may not have all the information, so the output may not be valid. So just the more detail you give the calculators, the more accurate you're going to be. One quick call out: change the default currency from USD to New Zealand. Often it remembers, but occasionally, I've been called out once or twice. You go through and think, oh, this price estimate looks great, and you flick it over to New Zealand. It's like, oh, that's bumped it up significantly. So just an awareness there. If it's not in the right currency, you can get caught out. And again, just a quick call out, there's plenty of vendor documentation for this out there as well that I'd encourage you to go and look at. Both Azure and AWS have their well-architected framework, a series of best practice design pillars, not only cost management, but covering other areas like security and resiliency and operational excellence, amongst others. Sort of documented on a per service basis, so it's worth digging into that. Then also there's service specific documentation, so I don't know, pick a service, an application gateway on Azure. You go into that documentation, it'll have more sort of structure and detail on the pricing models, sort of the background to how the calculator, those pricing calculators are giving you those figures, so you can get quite granular numbers there as well if you need to, but just making a point that documentation is out there as well. Noting that links on a presentation aren't always the most practical thing to present, but it's there. Right, so just quickly going to touch on some built-in tools for visibility. So this is really the dashboards within Azure and AWS. So this gives you that single pane of glass view of past, current, and forecast spend. Can be scoped how you need it in the Azure space, by subscription, by resource group, location, or resource tagging. The key to sort of point out here is use these tools to create a budget, a defined sort of budget allocation for a subscription for a project, and from that you can create alerts based around sort of thresholds reached. We're at 70% of the allocation, 80%, 90%, you receive alerts on those. Also alerts if you're forecast to exceed that budget, or additionally alerts around if there's anomalies detected in the cost. That will also trigger an alert. The idea here being you want to know early in the billing cycle if something unexpected has occurred and you're going to run up a large bill. If you're at the 10th of the month and you're already at 80% of your budget, you'd like to know at that point, not at the end of the month, at the end of the billing cycle, and have a huge bill to go back and rectify. So it's just about getting visibility, and knowing about billing. AWS, same kind of thing. This is just a cost and usage report from their console. But again, same concept. Create the budgets, create those alerts, get awareness, get that visibility of the spend, and know when something unexpected is happening. So I talked about some of those optimization techniques. So The rate optimizations is what we'll start with. So the idea around this is primarily a minimum commitment. So this is the idea that you commit to running your services on one of the cloud platforms for generally a 1 or 3 year commitment period, and then you receive discounts for that commit. So there's usually in the form of savings plans or reservations. I'll go into some detail on those two items. License mobility, so this is a way to make use of an existing investment in operating system and some application licenses from on-premise systems to bring those up into your cloud environment to save costs. So if you've already paid for a Windows OS license, don't pay for it again in the cloud, basically. There's a few conditions and sort of nuances to the way it works, but we'll go through that as well. And then looking at the use of spot instances. So this is the idea that a cloud provider has a huge amount of unused infrastructure to support, scale and redundancy and all these things. So spot are a way to make use of that unused infrastructure for certain workloads that it's suitable for at greatly reduced cost. Again, a few sort of caveats around that, which we'll go into. So starting off with the savings plan, so I said this is a minimum commitment model. So basically you make a fixed hourly spend commitment over a 1 or 3 year term to see the cost savings. I highlight hourly there because a lot of I think, at least in my mind, anyway, when we talk about cost spend, things are sort of done at per month sort of scale. So when you're putting in this figure, you want to make sure you put in the, what you expect to spend per hour rather than per month, because you'd be up for an interesting charge at the end of it. But to point out that hourly commitment is, it's 10 a.m. on a Monday morning. That hour, it's the same. You're charged at 10 p.m. on a Wednesday night. It's 2 a.m. on a Saturday morning. It's your minimum commitment for every hour over that term. And you can see up to around 65% saving for compute services on either cloud platform. Any usage above that minimum commit is charged at standard pay-as-you-go rates. So it's quite flexible. Basically, it's not tied to a certain region or service. You commit to spending a certain amount, and the cloud platform, in the case of Azure, will determine which service under the scope of your savings plan will receive the most benefit, and it'll apply the savings and then work its way down to the next lot of all the services available until the savings plan commitment is expired, and then we'll just go back to pay-as-you-go rates. But you don't need to sort of target specific services, specific regions, all those kinds of things. You just say, I commit to spending X figure per hour over 1 year, go, and let it do the rest. So it's the same concepts available on both Azure and AWS. So in Azure, it's savings plan for compute. AWS has a few sort of variations. They have a compute savings plan, which is a more broad savings plan. EC2 and SageMaker are a bit more narrow scope, but they can offer a higher discount of sort of 72%. So it can be used there, so there's different options. And important to call out, just if you want to make changes to the savings plan, it's important to review sort of past billing patterns and have a good idea of where you want to set that minimum commit. Azure savings plans, essentially the purchase is the final. So you want to have a good idea of what you want to commit to. You don't just go and put a figure in without sort of reviewing usage at a time. You might sort of get yourself a bit stuck. AWS, there is a 7-day grace period. And as I said, once you've purchased, you pay that committed amount for every hour of the term, regardless of your usage. So just to highlight that, just simple diagrams. So basically, in the sort of yellow boxes is our usage over time per hour, 1, 2, 3, and the green line represents our minimum commit spend. So first hour, we've hit up to that green line. Happy days, we've met the commitment. Second hour, we've gone a bit over. Someone something else up. So that purple hashed out is just a charge of pay-as-you-go rates. Third hour, we've scaled some stuff back and we haven't actually reached the commitment, so we've used up to sort of 2/3 of it. That's essentially a waste of money because we're still paying for that commitment. We haven't put anything behind it to make use of it, but that's a situation you don't want to get into. So you need to sort of find a figure. You review your usage, your cost reports, understand what maybe a good percentage. Maybe you want to sort of commit to 70% or so of your standard charges to allow for those sort of troughs and peaks, and sort of make the best use of it.
So that essentially is lost. You're not, if you had hour 4 and you went over again, it won't use that unused commit.
No,
It will go into pay-as-you-go. It's really...
It's done on that hourly basis.
But that green line is less than your pay-as-you-go, so you're kind of winning there.
Yeah,
you know? But
So
if you've lost unused commit, then you're losing kind of thing, potentially.
Yeah,
But
that's
the
right.
green line is much cheaper than your pay-as-you-go.
Yeah. Okay, so reservations are similar concept. It's another way of having a minimum commitment plan, so similar to savings plans. It provides a discount to commit to use specific services. I suppose they're less flexible than savings plans. These are tied to regions or specific services or SKUs, but they can provide a higher discount. So it might be in the case of Azure, you have a reservation on a particular VM family in the Australia East region, and you kind of get a little bit of movement sort of in that family, but you can't really use it anywhere else and other services. So it's really suited to continually running workloads. I've got this virtual server, it's this size, it's going to run for the next 3 years for the life of this project, and it's not really going to change. So that could be a good use case for reservations. They can be applied to many services, databases as well, for example. And these can coexist together, so you can have reservations and saving plans sort of in the same scope, targeted at the same resources. In the case of a resource being eligible for both, the reservation will apply because that would give you the bigger discount. Another break savings plan is just this license mobility that I talked about, and this is mostly from the Azure space, so this is features Azure hybrid benefit. So this is, as I said in the earlier slide, a way of making use of your existing investment in Windows or SQL licenses by using them on your Azure services. So there can be significant savings basically as removing that whole operating system cost. So the price of a Windows virtual machine essentially comes down to the equivalent Linux virtual machines without the OS cost. But it's not I guess a one-to-one translation. It's not that I have sort of one Windows license, one core, and I can bring that across to the Azure for one core. There's a minimum amount of 8 cores per license sort of block, I guess, that you can bring across. So if you had, say, 16 core, so 2 8-core virtual machines spinning, you could bring across 16 core hybrid licenses across the 2 machines. But if you had a 4-core virtual machine, you would still need to bring across an 8-core block, and you would lose 4 of those license cores. So it's not just a simple one-to-one. There is a specific hybrid benefit calculator separate to the general pricing calculator, so you can actually get into quite detail on the benefits and savings you'd get with this, so it's worth having a look at that as well. And just to call out that it does require active software assurance through volume licensing plans, so it's valid for the period of that software assurance time, and then you'd be expected to go back to the normal Azure OS-based licensing. Microsoft, I suppose, don't actively track this, but I suppose they reserve the right to audit your usage. So you're not there's no verification as you deploy you're using it, but you're expected to do the right thing. AWS has a similar sort of concept, although it's, I suppose, not quite as easy to consume. There's a bit of a sort of an activation process, and then you can't use the built-in machine images, your base templates, as you do with Azure virtual machines. You have to sort of create your own custom image and use your own media to make use of this license. So there's similar concept that's not quite as seamless, I suppose, is the key there, the Microsoft option. So just a quick example from the billing page. When you spin up a VM, just picked a random SKU. The one on the left, we have the Windows Server operating system included, $134 added to the price. When we turn on hybrid benefit, that's discounted, goes down to 0. So the figure at the top is the overall price. So a significant saving. And this can be combined with the reservations and savings plans. So think of the savings plans as, I guess, infrastructure related savings and commitment, and hybrid benefits obviously the operating system software savings, so they can be combined. So I mentioned spot instances as well. So this is that idea of making use of spare and excess capacity, infrastructure capacity from the cloud provider. So it's a mechanism to use that capacity for compute services at a reduced cost. So I guess the key nuance with it is there's sort of usage thresholds, knowing that spot instances can be stopped or evicted at certain times if that capacity becomes unavailable because a paying customer wants to use that capacity. Your spot instances could get stopped, they could get deleted depending on what you set. So it does make it, it's not suitable for all workloads. So you sort of need to understand the use case. So it could be ideal for services that maybe aren't time sensitive. If you're running a process and there is an interruption and your machine's evicted, not ideal, but not the end of the world if your service sort of spins up again a day later when there is capacity. So you just need to understand your sort of usage patterns and workflows and the suitability for this service. But stateless container workloads maybe, or dev test type workloads could be suitable there as well. And it is a dynamic price based on that available capacity in the target region. And each cloud will show you, I suppose, a history of the prices and in certain regions. So I've got a couple of screenshots of that. So in the case of Azure, over the last 3 months, this particular virtual machine size in nearby regions that you select, you can see which region has lower cost, so there's more capacity. So in this case, maybe it's better to deploy something in the Southeast Australia Southeast region instead of Australia East. It's nearly half the price. The eviction rates are pretty low. If you look at some of the US data centers, you get eviction rates 20% kind of thing, depending more utilization there, so they can be higher. So you can use this figure to say, well, the sort of trending cost for this machine is what 0.017 cents. Maybe I want to run this until it goes up to 0.05 cents. That's what I'm willing to pay. When I get to that threshold, stop the machine and wait for that capacity to come down, and then spin it up again. And AWS, similar kind of concept, right? So what's the cost history over nearby regions? What's the percentage saving we'll be getting? So again, you can make educated decisions on what thresholds you want to set for these machines if you want to make use of spot instances. One thing I will say on all these sort of reservations and savings plans, they sort of on the surface look like they sort of lean towards virtual machine type savings, but it's actually, I suppose, savings plans for compute. So the compute can be on the back end of container services on the back of serverless like saving application services, web apps, those kinds of things. So it's not tied just to virtual machines. You can make use of saving plans and reservations across a wide range of services. So it's not just saving that IaaS space. There's quite an area to make a saving there. Just a quick call out in the Azure side. You can set your subscriptions to be dev test. So this essentially
The locker.
applies the hybrid benefit type savings to Windows VMs. So basically removes that license costs. There's also some additional savings for some other services, database savings and app services and other things, depending on the service and SKU you pick. But the key thing is when a subscription is set to dev test, they're not bound by the SLAs that Microsoft provide because it is a dev test. So those SLAs are normally in the form, if there's a breach of credits back and those kinds of things, none of that will apply. So yeah, just be aware, but that is an option there when subscriptions are created to set that up. So you're looking at some usage optimization strategies. So this is, we've got our savings plans where we're paying a minimum amount per hour, per month for the service. Now these things are running, how can we optimize them when these services are actually running? So some common themes that we hear quite often. So right sizing. So this is, understanding your usage patterns of your services, your virtual machines or your PaaS services, understanding the series or family of virtual machine, and then the size within that, CPU, RAM, and storage, those kinds of things. With your PaaS services, what tier you select for the service, so, the basic, standard, premium type thing, and then there might be some compute sizing options in that. So it's being aware of how you're using those services and are you overcommit, undercommit, can you bring down overcommitment usage to save money kind of thing. And then from that, how can we auto scale? So basically increase the compute capacity that's back-ending those services as we need based on demand to provide acceptable performance. But then when that demand drops, how do we automatically scale back so we're not paying for unused capacity? So keep those costs optimized. and looking at the different scale options and pricing models within different PaaS services, or it's virtual machine scale sets or scale groups if you're looking at VM, virtual machine based workloads. In some cases, it's also looking at how low can we scale some of these services. You can get options to scale to 0 when there's no activity, you have no compute behind it, get minimal cost. But there's some considerations around that if you want to go down that path, and which services support that level. And I'll talk a bit more about that as we go on. And then idle resources. So a fairly common one. You're paying for what you use in the cloud generally. So if you've got something you're not used, dev test, shut it down. You're not paying for it. Even better if your processes are mature enough, destroy the environment and recreate it. If you're running infrastructure as code and deployment pipelines, you're well down the DevOps path, and you can spin up the environments quite quickly. Destroy the environments at the end of the week, spin them up on a Monday morning, obviously allowing time for the deployments and things to happen. But if no one's working on the weekend, you're just paying for systems that are sitting there. So it could be a quick win, and that's obviously dependent on the environment and the service. Another key one is identifying and removing orphaned resources. Probably an issue for environments that may have been around for many years and had a lot of churn of services, but we've got some dashboards and recommendations on how to identify some of that later in the presentation. So the first thing to point out for usage optimization is have a look at the built-in Azure Advisor and AWS Trusted Advisor. These are tools in both cloud platforms that will analyze your deployed services against those pillars of the well-architected framework. So what steps can you take to align what you've deployed to their recommendations? Turn on an auto scale or right-size some services or whatever the case may be, but this will regularly analyze what you have deployed against those best practices. And not only for cost optimization, that's what we're talking about here, but again, against all those pillars in the well-architected framework, so performance, security, reliability, operational excellence. So they're good tools to look at. These are some of those things that are sort of always there in the background, and you can often sort of brush over them because you're busy, designing, deploying a specific service, looking at the settings and nuance of that service. But it's worth taking the time to stop and look through the recommendations in both these tools, because it's there, to make things better for you. So as I said, it's not just the cost management, but all pillars of the well-architected framework to those best practice standards. All right, so probably the two most common things we hear with sort of usage optimization is right sizing and auto scale. So when we talk about right size, as I sort of alluded to earlier, it's reviewing what you're running, the services available and sizing options. Virtual machines are sort of fairly straightforward for sizing in terms of you pick a CPU and RAM type allocation, a family of VM, whether it's general purpose or more skewed for CPU or memory type use cases, different sort of families of servers. But PaaS services often have a compute aspect as well, depending on the pricing model you've selected. You can pick different tiers of the PaaS service, which would sort of allocate certain CPU and memory sizing. So being aware of that and what you're using and how you can sort of right size within those service limits. It's really a case of reviewing your usage patterns over time, sort of get that balancing act right. Over provisioning, you're going to be paying for stuff you don't use. Under provisioning can lead to poor performance. So you don't want to try save too much and then cripple your service and have other problems. So as I sort of said, the right sizing, it makes sense in virtual machines. If you've got a scale set, you can scale out more virtual machines, scale them in, but it applies to those PaaS services, the serverless container, those kind of services as well, where you have a compute configuration on the back end for what's sort of back ending those services. And then auto scale is using sort of automation there to automatically scale out and in the compute for those services. A lot of services, particularly in the serverless and PaaS space, have auto scale options available. In some cases, it's a case of just turning it on, and the platform will determine based on utilization when to scale things out, response times and performance metrics. Other services have rule-based alerts. You can specify when you want things to scale out or scale back in. You define those rules. It's not kind of as automatic, but it's still, once those rules are set up, it is auto scale, but it does require you to set some stuff up at the head time for those rules. So some services do offer that idea I mentioned earlier of a scale to 0, or if you're using a sort of a serverless tier, it could be an auto pause kind of feature, where if there's no activity, and it's more a database kind of feature, there's no activity in the database, it goes into a pause state, and then when there's another transaction, it'll start back up. It can be a great cost optimization tool, but I guess understand the implications around scaling something to 0 and how long it takes to go from 0 back to 1. If there's some kind of compute resource, it's essentially VMs behind the scenes starting up to go from 0 to 1. Do you have to allow for that time? Is there not some kind of warm kind of state? There's a machine there kind of ready to go, so that scale up time isn't too much. But I guess the key is that look at these options, but don't get caught out when you're waiting for something to scale from 0 for a few minutes and impact your services. In the case of some PaaS services, we talk about stopping services to save money. Virtual machines are pretty straightforward. We can stop those. You don't pay for when they're not running. Some PaaS services you can stop as well. Some are available from the portal, but others it's through command line, PowerShell, these kinds of tools. So there are ways to stop, particularly in dev tests. So it might be like a application gateway or a firewall, or some other fairly expensive service that you're still paying on a per hour runtime. It makes sense to stop those where you can. Again, allow for startup time on those. So it's probably not a production thing you'll do. A lot of those services you want to leave potentially running all the time in production, but if you had a dev test environment, you might want to stop some of those services. Another one that's worth looking into is to upgrade to the latest generation of a service. There's always often V1, V2, V3 of a service. Old services get end of life and it's cost to upgrade, but it's worth looking into the latest version of the service. I have an example of that here. So in Azure, you've got Azure Managed Disks, disks attached to VM. So it's a premium SSD tier, version 1 of this tier. So when you select a V1 premium SSD disk, the disk size and the performance, so that the throughput and I/O were linked. So if you needed a fairly high performant disk, you would basically need to choose a large disk size to get those performance metrics that you needed, and then have a significant impact on cost. With the premium SSD V2, those figures can be set independently, so you can pick the metric that's needed and not spend on what you don't need. So just as an example, this is the calculator for the V1, so you can see where the red arrow is. If we wanted sort of that high 7500 provisioned IOPS, we need to sort of the performance there. We're sort of stuck with a fairly large disk size, and we're paying for a lot of capacity. If we only needed a couple of hundred gig of data, we've got a much larger disk than we need. With the V2, those are now 3 separate configurable options. So you can say, I want the smaller size, but I want the IOPS of the capacity. And just to point out the price, $425 for V1 versus the $113 for V2. So this is just one example of one service, but the idea is that understand what's coming with new versions of the services, how pricing models change, pricing options change, and what you get out of it. It can be worth looking at some of those paths to upgrade. Just wanted to call out a couple of platform-related services in the UC optimization. So around the networking, obviously, virtual networks, subnets, these kinds of things don't attract costs, as I mentioned earlier, but traffic flow does. So when you're designing your networks and connectivity, be aware of the path that traffic's going to take. In a general sense, you pay for traffic leaving these cloud environments. So whether that's out to the internet or to on-premises, you're going to pay for that data flow outbound. If you're going between networks within a cloud, in the case of you have network peering, you're going to pay for the data transfer over that peering link. Or if you have private connectivity, so in the form of a private endpoint in front of a public service, you want private access to a database or storage account, you pay for traffic through that private endpoint as well. So just some awareness, really, it's around the traffic flows. Network sort of PaaS type service, so this is like firewalls or load balancers, these kinds of tools. They'll generally have a fixed price, per month running time, but there can be a per gig processing cost as well, so be aware of those data flow costs. And these network PaaS type solutions can often include auto scale, generally based on demand, they'll scale up, load balancer. If you have a lot of high demand, a lot of connections coming in, auto scale to add a second instance of a load balancer, you're going to get charged for that second instance as that spins up. So be aware of those things happening. It's worth finding out where you can, maybe be aware of those auto scale events, notifications, alerts, those kinds of things. So you can have some expectations when costs would increase because of those. Still earn that visibility. On the storage side, so with blob storage, you can implement these lifecycle policies. So basically automatically moves data to lower cost tiers based on access frequency. So this is where you have, in Azure, you have the hot, cool, cold and archive tier, and you can set thresholds of when data gets moved between those tiers. The idea being it's cheaper to have data on the the archive and cold tiers, just have data sitting there compared to having it on the hot tiers, but the cost to move that data around increases as you move down to the colder levels. So hot, it's more expensive to have it on the disk, cheap to write to it and read from it. As you move down to archive, cheap to put it on the disk, costs you nothing to store it, but when you want to pull it out, you then will get charged a lot to pull it out of the archive. A key thing to point out is just to be aware of early deletion fees, particularly out of the archive tier. In Azure, for example, if you delete or sort of modify, delete, overwrite data in the archive tier earlier than 180 days, you can be charged for that. Cold 90 days, cool 30 days, so be aware it's not just you can put something in for a few days and pull it out. There are early deletion fees that could hit you at an unexpected time. Really identify if and when you need to do that multi-geo, sort of multi-region replication, sort of based on networking a little bit, but data that's going to traverse between two Azure regions, Australia East, Australia Southeast, between Sydney and Melbourne, you're going to pay a lot for that replication of that data. So, if you have the reliability requirements for multi-region for your application, fine, do it. You need to meet that requirement, but be aware of those costs and do that selectively. Don't just do a general let's replicate everything everywhere because you're going to pay for that. So just continuing on, just a quick one on logging. This is one of those ones that can add costs. A few people laughing in the background. That one can add costs quickly and unexpectedly. People, on the sort of thing, logging could add costs, but it's often based on logs being ingested into a logging platform. So you need to be selective about what data is being collected. You don't need to log every event. Every log, doesn't need to be captured. You can tune up that logging thresholds when something's happening for troubleshooting, then tone it down when you don't need. When it's particular, when you fix whatever you were trying to troubleshoot, and you can configure a baseline logging through policy for some consistency. So if you had a central logging platform, you want to provide a standard configuration. You can push that out centrally for all teams consuming your environment, and you've got a bit of consistency and expectation there of cost. And just some ideas around further sort of policy and governance controls. Don't often sort of think about them so much in relation to cost management, but there are some policy options that could assist. The first one that comes up everywhere and definitely worth doing is enforce that tagging of all your deployed resources. So this is tags on who deployed it, why, is there a project code, when, all that sort of metadata type information. You can create custom billing reports based on those tags. Helps you identify why services were deployed, who deployed them. It's just tag all your resources basically. You can look at limiting regions that you can be deployed into. Often it might be more compliance type scenario. We can stay in one area, but if teams can only deploy into one or two regions, you limit your geo-replication risk. Unnecessarily replicating data out of your region, paying for that data to go somewhere else. So you can kind of help keep control of that. As a follow on from that, you can also, if you want to limit which services you can deploy through policy, if you didn't want to deploy a certain service for a reason and not pay for that, you could do that. I suppose be careful with that kind of thing. Obviously, you want teams to be able to use the services available in the cloud on these platforms. So that is an option there, though, if you wanted to go down that path. Right, so just want to quick run through a few workbooks and some resources available to see some of this information actually in the interfaces in the portals. So to start with, on AWS, this is Cost Optimization Hub. So this is basically a single pane of glass view that collates all the cost optimization and savings opportunities in one place. So it basically pulls in that AWS Trusted Advisor that I mentioned earlier. There's an AWS Compute Optimizer and just general cost management best practices. So you can identify, idle resources, unused resources, what right sizing options are available to you, what the benefits of saving plans and reservations are to you, and the actual savings speed you'll get. So sort of a good, fairly neutral, a single sort of pane of glass view there. And that, yeah, as I said, does provide that figure for the savings. On the Azure side, so there's a number of workbooks that I've used in the past that are quite good. This first one, Orphaned Resources Workbook, there's a number of ways to view this information, but I quite like this one, as this overview page in particular, because it's a good one-page view on any orphaned resources you have, which of them might be generating a cost. So this is managed disks, not attached to a VM or service, public IP addresses not attached to a network adapter, load balancers with no back-end pools, so they're just sitting there doing nothing. These things are attracting a cost just for being there. So if they're orphaned, delete them. This is probably one of those things that if you haven't sort of run this before and you've got a cloud environment that's been around for several years and a lot of churn, you might have, say, a large number of orphan managed disks that you weren't aware of. So you might go and clean those up, and so you'll see those savings, those ongoing savings from that point forward. But you'd like to think, if you run this tool again, look at this dashboard again in a month's time, you're probably not going to have the same amount of managed disks because you've cleaned that, the last 5 years of cloud usage up at that point. That being said, if you are finding you're getting 20 or 30 orphan managed disks a month, there's maybe some process or something going on you need to look further into. But yeah, it's a good view for some quick savings if you've got a lot of orphan resources. Then those options along the top where we have compute, storage and database, etc. That's just delving deeper into the specific services to get more information on what the actual resources are that are orphaned. So the next one is just a cost optimization workbook, again in Azure. So this is providing a bit like that, the AWS page. It's providing details on sort of the rate and usage optimizations and some savings there and what we'd achieve through the use of savings plans and reservations. And then pulling some of the Azure Advisor recommendations for those usage optimizations. Again, pulling all that information into sort of a single place, into this single workbook, making it visible to you and easy to consume, and action is the key here, rather than having to click around through different subscriptions or different scopes. Another one, just wanted to quickly call out the governance workbook. So this does have some cost management features, the cost management more sort of cost usage, I suppose, than strictly optimization. But I just wanted to bring this up because it does have some useful views as well. Particularly, I like that services retirement page. So this will basically look at the services retirement status from Microsoft when they're going to end of life services and how that aligns to what you have deployed. So you have something running that's going to end of life in 6 months. It'll highlight that to you. If you weren't aware, you can obviously take the action to migrate or do what you need to do with that. So it's quite a good tool. So these last two workbooks are part of this Azure FinOps toolkit. So this is a collection of open source tools and resources that Microsoft have worked with the FinOps Foundation to basically put you on the path to sort of align to a wider FinOps framework. So those two previous workbooks have been incorporated into this toolkit. This is sort of actively being developed. I think when I put this slide together, it was version 0.04. I think it's now up to 6. So every few months it's getting new editions. So there's a lot of information in there. If you sort of want to move just beyond strictly, cost optimization and more to that sort of wider FinOps practice, that sort of collaborative cost management approach, the sort of cost accountability, trying to determine value from services as much as sort of the cost and these kind of things, then it's a good thing to look into. There's a lot of resources there from the FinOps Foundation. So just wanted to round out with a few key takeaways from this presentation. So first one is just that early visibility. So this is going into those management consoles, creating the budgets to understand your cost allocation, but really setting up those billing alerts. Know when an anomaly or something unexpected is going to happen early, and take action rather than waiting for the end of a billing cycle. Then you find there's a problem and you've accrued a huge bill. So the sooner you see something unexpected, the sooner you can rectify it, and you're not going to get charged for that. Look at those rate optimizations. A bit like I mentioned with Azure Advisor, it sometimes feels like the savings plans or maybe reservations to a lesser extent are sort of overlooked as you're going into the platform and deploying a service and configuring the specifics of a service as you need it to be. You sort of glance over the savings plans options, but it's worth stopping and having a look. Just by deploying a savings plan, you could get a significant saving just out of the box with minimal configuration. If you know you're going to commit to spend, whatever the figure is over the next, 1 or 3 years based on your sort of project roadmap, services life cycles, those kinds of things. Put in a savings plan and just start getting some of those savings just from using what you're already using, really. And that idea that this cost optimization, it's not a one-off activity, right? It's continual improvement, a continual process. Regularly review your cost usage, look at the patterns over time, feeds into right sizing and scale and those kinds of things. So it's, at a first run, there might be some low-hanging fruit. Could be some of those orphaned resources, getting some savings plans going, and then as you go along, it might be more detail to work through. But the point is, it's not just a once and done. You continually review this and optimize and make changes where you need to. And that is it. Thank you for listening to me go on for the last.
Thanks, John. Do you have any questions online? Do we have time for a quick Q&A?
Yep, you're good here.
Are there any questions from anyone in the room or online?
Yeah, I have one, Tavita speaking. You know how you can choose the scope for reserved instances to whether it's, say, it's on the subscription level. If that subscription is destroyed, what happens to the reserved instance? Does it attach itself to its replacement, or?
That is a very good question.
Yeah.
Yeah. So reserved. So reserved instance specifically, not a saving plan. I mean, the reserved instance is linked to a region and the sort of the resource type. So there are sort of more flexibility in reservation sort of transfer options than compared to savings plans. So you may be able to transfer that.
Right. Okay.
I'm not sure that it's deleted automatically, but that is a good question.
John, for me, the implication of the whole presentation is really there's a capability you may not have today, especially for those who are on-prem or on their journey to the cloud. And basically now you're having to build this, and there's a kind of balance here between spending time on the stuff, there's a lot of complexity, and I think these tools simplify that in terms of you having to look at all the stuff, but obviously versus the savings, I think that's the kind of change. But who does this work within an organisation? Is it someone in finance, or someone in IT?
It's a skill set.
This is a lot of these. This is one example of what comes along with the cloud. Some things are simplified, but there are new things. Some things are a little bit harder.
So this is where, I guess, in that on-prem world, it was the management or commercial teams, finance teams that worried about the capex cost buying.
More often a one-off.
And the engineers, platform guys deploying the stuff. Got my hardware, I can deploy my VMs, it doesn't cost me anything more to deploy. Obviously in the cloud, it doesn't work that way, and you're getting charged, for everything you deploy on a pay-as-you-go basis. So it really comes down to, you're starting to get to that sort of FinOps kind of approach of, having some accountability for spend across all the teams. So it's not just the, finance team or managers, it's product owners, it's the engineers, it's everyone having some accountability, and then working out, producing some value out of what you're deploying as well. How do I know I'm getting value for this service that I deploy?
That's why tagging is important as well, because of course they have responsibility with it. What's this thing? I don't know. We built it a year ago and no one owns it.
And now often to leverage the savings, you actually need engineering. Where, you need to, scale the thing up, scale it down. Those are the kind of things you need to do.
We all like to go sort of that first slide, move along that spectrum to the serverless cloud native type tools, and think it's we just sort of spin it up and use it. But there are still things to know, configurations to make it. It's not just a case of saying turn on, SaaS services aside, I suppose. But when you're talking about containerized platforms or serverless type things, there are still settings and tweaks, and you need to understand what you're doing.
And also your point you raised earlier, latency and all these other conversations that come into it.
So this is kind of like my observation is that often the cloud ops team will try to run quite a tight ship, but when you have that subscription democracy in those DevOps teams, they don't necessarily have the same discipline, and sometimes within those landing zones, things can get a bit sprawly. They're like, stuff. And the cloud ops team, they're kind of trusting. They're just going, well, I don't know what's going on in there, so I'm just assuming it's all required. And I wonder if maybe the mentality needs to shift so that some of the stuff can get managed in the DevOps pipeline, so that as well as all the other things that you do in your pipelines, you're starting to look at optimization and how are we actually doing the most efficient things here, and is there any redundant resources sitting out there, so that it's kind of, because like for the DevOps teams, they don't think that way. They think in terms of their pipelines. They think I'm deploying, I'm getting something working. I'm just wondering if they should optimize as well.
DevSec FinOps.
I was going to say it's taking what DevOps did to those teams, having that DevOps culture and all the collaboration and everything that comes with DevOps into the FinOps space, and having a more collaborative approach to cost management, that cost optimization, and having that accountability really is the key thing there. People are accountable and know what they're deploying, and it's not just someone else's problem.
Well, that's why I think the product owner needs to have awareness, right? If they just kind of trust, the guys tell me that I'm doing things the best way, so I just believe them, rather than pushing on it and saying, actually, my infrastructure costs are not justifying my income.
And it's also doing it the best way for, I suppose, service availability and performance and things, but not necessarily for cost. So where does it sit on that balance of those well-architected pillars as well?
A couple of questions online there.
So Mark Smith's asking, do you think Microsoft and AWS will come out with a savings plan that have rollover features like you get with mobile plans, under commitments in 1 month being added to commitment in month 2?
I haven't heard of it specifically, but I'm not going to say no. These kind of things might come. These reservations worthy sort of they've been around for many years, and savings plans are supposed to the newer version of that with the flexibility there, and they're always getting updated and new things added. So it's possible it's not a bad idea. I mean, they want you to commit. They're not there to have you commit and not use the cloud. They want you to use it. So it's kind of trying to optimize that.
We've got Narayan there.
Hey, John. Thanks for the great presentation. It was pretty quite a lot of things you actually covered, especially on licensing part of it. With the bigger organizations, it's always a complexity with licensing and transferring those SQL licenses and everything. So does any of these out of these big three public cloud, one works better with licensing compared to other ones, especially with Microsoft ones?
Yeah, so in terms of those Azure hybrid licenses, hybrid benefit, I would say it does work sort of best on the Azure side. I mean, Microsoft sides, I suppose. As I said, it does require the active software assurance on the license. So that's your purchase out of your volume license plans, those kinds of things. So, but it's pretty much an option you turn on. I want to I want to enable hybrid benefit, and away you go. It's quite simple to consume. As I said, Microsoft don't sort of check or enforce. There's no validation there. They, bit of a trust exercise. I guess they could, in theory, audit your use, and go from there. But it's quite easy to consume it on the Microsoft side in Azure.
Right. And with AWS or GCP, if we have to actually take a lot of payloads from Microsoft products onto them, do they actually come on negotiation if we want to? Does that route works? What you see on the pricing model and everything, what they show, that's for a general purpose, right? So with the bigger organization, do they come on the table to do the negotiation at all?
They often will. If you're a larger organization, there's going to be discounts across the board. Sort of applied on things they want to get in your business, so they're going to offer those kinds of things. There's all sorts of licensing models in general, and sort of base level discounts that get applied across compute, not just licensing, but those larger organizations have the conversations with the cloud vendors. there's discounts, they're fairly, fair discounts out.
Okay. Cool.
Yeah,
Thank you.
I've seen a few big banks have negotiated specific agreements for pricing and
This is what scale it is, because of course New
Yes,
Zealand scale.
I don't know exactly some.
It's probably
Definitely at that scale, I think
yeah.
there's variation where you fit in, in size.
So just one more around the ownership of the costs, right? I know we talk about the cost optimization, right? So there are those techniques and working it out, right? But I guess at some point in time there is where does the ownership sit for working out whether it's the right cost coming out, right? Because you can't just simply say, hey, from a cloud operations team, hey, we'll switch this off because this is not being used, right? But you might want to transfer those costs and the use of tags and stuff like that, which you need to pass on and say, hey, this is what is going into the cost that is going into your cost center, right? And approve it or whatever, right? Something on those lines is a process, right?
Yeah, and there's processes to work out there. It's also working out, on the other side, what is the value you're putting this cost to run these services on the cloud?
Yeah.
What is the value we're getting out of this offering we've put out to market? Is it costing us, 10K a month to run this stuff, but we're making 500K on the other side of the service? There's some value there. So can you work out that value figure? Can you attribute that to the infrastructure costs and how that's sort of played around as well? That starts to come through those FinOps sort of practices. It gets more than just, cost optimization, but it's a whole collaborative approach.
These things are often easier when they're implemented in organizations that have a proper product ownership structure. Because
that's a good way
Yeah.
to organise the cost.
Yeah.
If you've got the maturity into the organisation, the intersection between IT and the business.
it becomes difficult when you don't have that. But to your point, how do you assign these costs? Who's responsible? Yeah.
Yeah, because cost optimization on its own will not work unless you don't really know where.
We talk to the owner.
And also you've got to decide what your SLAs are and your OLAs are, because that will increase or decrease cost also.
It's one of those things that cost optimization is a FinOps.
Yes.
So FinOps includes cost optimization. It's part of the bigger sort of culture process.
I noticed some sniggering when we mentioned the logging, and you might think that's a bit obtuse, that's a bit of surgery, but I think there's been a few in the room here who've experienced that as one big one.
I've had some interesting, I suppose, scenarios, a combination of factors where an application had a team left a high level of logging, trace level of logging on an application because they were troubleshooting an issue and didn't turn it down for whatever reason, and it was happily logging that to the logging platform in Azure at the time. That combined with Microsoft making a change with the way it stored those logs from sort of it's got application insights, the native logging platform. It used to sort of just store the logs of its own mechanism behind the scenes. Microsoft said, no, we're going to shift those logs to log analytics workspace, the standard sort of logging tool that does have the ingestion costs. So suddenly this trace level logging that was hammering out logs every second, hundreds of logs hitting it, see the cost for that log analytics workspace ingestion go to 5K, 10K, I think it got towards 20K plus for the month. So I think you got to go through, sort of review the tables in the workspace, narrow it down to which resource group the logs are coming from, and go back to the team and say, look at this. So, but that's part of the exercise. You've got the alerts on the budgets. Hang on a second, there's an anomaly, and we knew about this, at day 10 of the month rather than day 30. So you pick it up. Yes, having an unexpected 5K logging bill is bad. It's better than having an unexpected 40K logging bill at the end of the month. So it's it's that visibility and getting access early.
Nice. Okay, I'm just conscious of time.
Thanks, everyone.
But thanks so much for that really informative webinar. John's obviously created a little bit of chatter in the room, and I know we've had a couple of questions online. John doesn't know this yet, but look, if anyone else online does have any other questions, please feel free to reach out to John. I'm sure he'll be happy to have a chat, but thank you so much everyone for making the time to join us today. It was lovely to see you all. Thanks, John.
Thank you.
Thank you.